Welcome back, everyone. It's now time to switch gears and go back to the linear regression project. In this lecture, we're going to have an overview of the project tasks. Now that we've actually learned about feature engineering, things like dealing with outliers and missing data, cross-validation, and grid search, we're going to test your new skills by revisiting the Ames final data frame dataset that we set up for us in the previous section, and we're going to have the linear regression project on it. Let's check out the notebook for the project. Alright, here I am at the project exercise notebook, which can be found under section 10 called cross-val and linreg project. So that's the folder, basically the same folder where all the cross-validation notebooks are. And if you go ahead and scroll down, essentially we have the tasks to be completed below. And keep in mind that this project and this exercise is a little more guided than future machine learning projects that will be more open-ended. What we have here are the imports you should run, and then the exact CSV file you should read. So if you run this notebook from its original location, go ahead and read in Ames final df.csv. I highly recommend that you read in this specific CSV just in case you made any typos while following along with the feature engineering and data preparation lectures. It should look like this. It should have 5 rows and quite a large amount of columns, 274. You can check out the info, and then you have tasks to kind of fill out and try to figure out what the correct format is. So you'll go ahead and move along here as you separate out features from labels. You'll use scikit-learn, and then we do advise that later on we'll use a grid search strategy. So set your test proportion to smaller, like 10%, as a final holdout test set. And if you want to actually compare your results to the notebook's results, you can specify a random state of 101. And then you'll notice that the dataset feature has a variety of scales and units. So for optimal regression performance, you can go ahead and scale the features as we've already discussed before. And then go ahead and use an elastic net model. And the elastic net model will have 2 main parameters, alpha and L1 ratio. So then we want you to use a grid search CV object to run a grid of the best parameters search. Now keep in mind, as you're running a grid search, sometimes certain combinations don't really make sense or don't really resolve. So in case you're curious about warnings you may receive for certain parameter combinations, I do have a link here that will actually take you to an explanation to Stack Overflow, where if you're trying to run something like lasso, keep in mind lasso could be an option if your elastic net range goes from 0 to 1 as the ratio there. And there is this kind of user warning that you may see, and there's an explanation here for if you want you can edit the tolerance, or you can just kind of ignore the warning. So go ahead and come down here, then you'll display the best combination of parameters for your model. In this case, this is what we got for kind of our experimentation, and then you can evaluate your model's performance on the unseen 10%. Obviously, you can just try a straight ridge or straight lasso or polynomial, etc. Lots of different things you can try here to try to improve on the performance. We would expect you that if you do the exact same train test split we do, on the test that holdout test dataset, you should try to achieve very close to a mean absolute error of around 14,150 or 149, and a root mean squared error of about 20,532. Okay, best of luck on the project, and we'll see you in the next lecture where we go over an example set of solutions.